Saxon Algebra 2, Lesson 20. Greetings, my students. We have a two-topic lesson. They're both really algebra today. A total of 4 examples, 3 on the first topic and then 1 on the second. First, we're going to talk about simplifying radicals. And you know what? I love simplifying radicals because it is perfectly illustrated by the story of the 3 little pigs. You know the story of the 3 little pigs. They each went out and they built their own houses and were living independent lives until a terrorist blew into town. Yes, literally blew. The big bad wolf came along and started trashing their houses. But what happened was that then they just ran from one house to the next until they were all 3 together in a house that was strong. And then they were able to overcome the big bad wolf. It's a beautiful story, unless you're a wolf. And then you just have to go eat somewhere else. So the rules of radicals are illustrated by that story. If you have pigs in separate houses and you're multiplying them, you can just scoot them in together, right? This is how they survived. This is how they started out, though, assuming when they were young piglets, they lived together in the same house. This is when they chose to strike it out on their own, right? So you can do this in either direction. All right, the other thing that is implicit in radicals is that 2 matching pigs in the house is equal to 1 pig out of the house. Oh, 2 pigs in the house that match equals 1 pig out of the house. We're going to use all of these ideas in the problems. And won't that be fun? Example 20.1. Simplify. Okay, 3 square root of 50 minus 5 square root of 200. Now, remember that the rule for adding and subtracting radicals is that they have to match before you can add or subtract them. So at first glance, we look at this and go, no, square root of 50 and square root of 200 do not match, so forget about it. We're not going to be able to do anything with this problem. But we could break down the numbers that are here using these ideas. We can break these roots down. We can simplify the radicals, and maybe after we're done simplifying, we'll have better luck. So how do we go out about simplifying them? What we have to do is break this number down into all of its separate little prime number piggies. Piggies are prime numbers. They like to be broken all the way down. So we have to make little prime factor trees. This is 25 times 2. 2 is prime. And then 25 would be 5 times 5, right? So we break it down. This one, I'm going to do 2 times 100, prime. And then I'm going to go 10 times 10. And then each of these is going to be 2, 5, 2, 5, right? I circle all of my primes. And now I'm going to rewrite this, which might be overkill. You don't necessarily have to show this step. Well, no, I think you should in your homework. So we have 3 times the square root of 2 times 5 times 5 minus 5 times the square root of, let's see, we have 3 2's and 2 5's. Now, remember what I said here? 2 matching pigs in the house equals 1 pig out of the house. So this 5 is a pair of pigs. We can bring it out, and what we have to do is we have to multiply it by this wolf who's sitting out here. The metaphor breaks down at this point. I have no idea what that has to do with the story, but 2 pigs feel brave enough to jump out, and as one, they confront the wolf. I guess that's what it is. Over here, here's a pair of pigs. So this 2 jumps out and multiplies himself by the wolf. Wolves stay out of the house, by the way. The numbers inside the radical sign are pigs. The numbers outside are wolves. 2 pigs. It takes 2 pigs to jump out together because the wolf's a lot bigger. They have to be brave. And then we can bring out this pair of pigs as well, right? So that's 5 times 2 times 5. So what are we left with? Oh, look what happened there. Okay, so we're gonna have 15 square root of 2 here, right? When we simplify this, 3 times 5 is 15. The 2 is what's left. Minus, let's see, we took out a 2 and a 5, so that's a 10. We multiply it by the 5 that was there, that's 50. And all we have left over here is square root of 2. Look at that. And so our final answer, and then remember, once we get these to match, once the pig houses match, then we can just turn our attention to the wolves and add and subtract those. 15 minus 50 minus 35 square root of 2. Oh my gosh. That's kind of fun, right? Pigs jumping out. I think they jump out the chimney, right? Where they jump out of the house like that. Okay, let's do another one. That was so much fun. We'll do some more. Example 20.2, los dos. Ready? 3 square root of 2 times 4 square root of 12 times 2 square root of 3. And John uses a dot to show the multiplication. Now, the rules we talked about before, those are the rules for adding and subtracting. Of course, it would be way too easy to just have the same rules for multiplying, but they're not. To multiply, I have a different rule, and I'm going to tell it to you. But first, I'm going to write it. I will say this over and over again, and I hope someday you're sitting in a university level math class and your teacher's talking to you about simplifying radicals and this expression jumps into your head. That'll make me happy. When we multiply wolf times wolf and pig times pig, right? We multiply all the wolves together and all the pigs together. We never multiply wolves and pigs to each other. So here are my wolves, 3, 4, and 2. Let's multiply them together. 3 times 4 is 12, times 2 is 24. And then we multiply all the pigs. 2 times 12. Let's do 2 times 3 first. That's 6. 6 times 12 is 72. I know that. Oh, that's fun, isn't it? All right. Now we're ready to simplify. And let's break that 72 down. Well, we know it's 2 times 3 times, or 2 times 12 times 3, right? Because we just put all that together. 2 and 3 are prime, and then this one splits out. It's 4 times 3, so it's 2 times 2 times 3. Okay, so I am able to get my prime factors. There's quite a few of them. But now I see there's pairs of pigs. There's a pair of pigs. So I can take this out as a 2. And here's another pair of pigs, so I can take out a 3 as well. And I'm just going to be left with that 2 right there. 3 times 2 is 6. 24 times 6. Let's do that one. 24, 2, 12. So my answer is 144 times the square root of just that, 2. Oh. Okay, make sure you remember this rule for multiplying radicals. For adding and subtracting, we have to make them match. Okay, let's write that down. 2 add or subtract. Pigs must match. And then you just combine the wolves. To multiply, it's wolf times wolf, pig times pig. Okay, good. Now let's do one more, and I need a fresh page. That's my study tip of the day. If you're ever feeling frustrated, like you're doing a problem and you're having a hard time of it, or you're just sick and tired of the whole mess, just flip to a new page. It's so refreshing. It just makes you feel like all of that mess is history and you're fine. Okay, ready? 4. We're supposed to simplify this, whatever that means. Let's look at it. As I write it down, I realize, oh, it's a distribution, right? There's the binomial inside, there's a minus sign connecting them, and this is what's on the outside. So I'm just going to multiply like any distribution, like so. As I multiply, I have to remember wolf times wolf, pig times pig, right? So I don't lose my head. So I start here. Wolf times wolf is 8. Pig times pig, I'll just write this, but obviously we can simplify that, right? Because we have 2 matching pigs of 3, or we can also see, oh, square root of 9, that's 3. Let's do that in the next round. Minus wolf times wolf. There's an invisible 1 wolf standing guard there. 1 times 4 is 4. Pig times pig, square root of 18. Okay, so we've done our multiplication. Now we can simplify. And this, like we said, this is 3 times 3. That's a pair of pigs. They come out. We multiply by 3, and all that goes away. So this becomes 24. 18, let's see, that breaks down into 9 times 2. 2 is prime, and then 9 goes down to 3 times 3. So we take out the pair of pigs. It's 3 times 4 on the outside. So there's the minus sign. 3 times 4 is 12. And then the 18, I've taken those pair of pigs away. They ended up right there. So all I'm left with here is a 2 pig. And that is our final answer. Oh, I thoroughly enjoyed that. I hope you enjoyed it 1/10 of what I did, because that would be satisfying. Okay, one more example on a different topic. We're in the world of graphing, and we're going to talk about parallel lines. Now, let me show you John's picture. Here's a graph that has some parallel lines drawn on it. Don't worry about reading the little details. I'll tell you what's important. All of these lines have the same slope. Does that make sense? Of course, if you just think of it logically as shapes, don't worry about the mathiness of it. If lines are parallel, that means they never touch each other. That means they must be tipped at exactly the same angle. Otherwise, they would touch, right? If one of them's a little more straight uppy or a little more flatty than the others, then they're not going to maintain that perfect spacing. They're going to drift towards each other. Now they have a different y-intercept, as we can see. They're crossing the y-intercept at different places, so their b is different, but lines that are parallel have the same slope. Oh, that sounds like something that needs to be embroidered and hung on the wall. I will just write it down. Okay. Give you a second to finish your writing. Lines that are parallel have the same slope. Remember, the symbol for parallel lines is a pair of parallel lines. It looks like 11 in parentheses, but I'm really just showing you that symbol. Same slope is m. All right, now how can we use that in a problem? Oh, I was hoping you'd ask, because I have an example here that will illustrate. Find the equation of the line that is parallel to the line 2y minus x equals 2 and passes through the point 3 minus 1. Okay, so here's what we're supposed to do. We're supposed to find the equation of a line, y equals mx plus b. We know that our line is parallel to this line, and this pair of points is on our line. So step 1, we find the slope of what I call the other line. All right, here it is. However, it's not in the proper format, and look at me, looks like I made it not equals 2. 2y minus x equals 2. Okay, we need to get it into the proper format, so let's kick the x over. 2y equals positive x plus 2, and then we divide away that coefficient. And so we get y equals 1/2 x plus 1, right? All I did was I took the x divided by 2 and I kind of pushed them apart so that I could see the fraction of the slope without the x being a part of it. So you can do that. X over 2 equals 1/2 x. 1/2 x equals x over 2. You can change it in either direction. I just yawned. I have to confess. All right, so the slope of the other line is this. So that's also the slope of our line, right? So our slope equals 1/2. Good to know. Now, we're going to use this slope that we just figured out and this pair of points that lies on our line that John gave us. We're going to use that information to solve for b, because then we'll have what we need to write it. All right, so I'm going to write it here and then I'm going to copy it onto the next page and solve it. So our x and y points are this. So y equals -1. And again, I'm putting it into this format. Equals m, that's 1/2, times x, which is 3, plus b, which we don't know. All right, this gets copied. All right, I feel good about this so far. This I can rewrite as just 3 over 2, right? 3 times 1. And I need to subtract that from both sides. That will make everything cancel, and I'll be left with just this. Over here, I need to simplify this. I need to change this number into a fraction that has a 2 on the bottom. So that would be -2 over 2, right? That's the same thing. Now I add and I get -5 over 2 equals b. Beautiful. So now I remember from the other page that 1/2 equals our m. And so I can write the equation of our line. It's y equals 1/2 x minus 5 over 2. Yay! Okay, so the moral of the story is that parallel lines have matching slopes. And if we're given another line and told that it's parallel to our line, then if we can figure out the slope of that line, then that's the slope of our line too. Oh, that's cute and fun, isn't it? I think it is. You probably just think it's one more fascinating fact to shove into the algebra quadrant of your brain. And, you know, I'm for that. Okay, guess what? Oh, look, I get to check off 2 lessons at once. I get to check them off when I complete them. And you know what? I'm really behind on my parents' signatures, which, you know, is going to be a challenge because both of my parents are no longer on this earth. So I'm going to have to find, someone's going to have to adopt me. I need a math mom to check my work. Maybe you guys would like to be my math moms. Come to my house and sign my paper to say that I taught. Okay, I'm done. And I think I've said more than enough. Okay, goodbye.